If you wanna know how the simple prediction models works, you are in the right place. Today I will show you how to get one output from the n-dimensional input. I will explain you everything step by step on the Titanic. There is a parallel universe where the Jack and Rose have watched this video and they survived, but in our universe they both died. I will explain you three concepts before our machine learning algorithm. The first one you probably all know, it is the linear function. The equation will be y is equal to a times x plus b. And what are these letters? Y is the output value, X is the input value, and A is the slope, how much is the function increasing or decreasing. B is intercept, is like the starting point from which function is starting. Let me show you. There is a boat from Titanic, and this is the first floor. This will be 1 on the x-axis, the first floor. Here there will be floors. That's our y. And if I draw this line, the y will be equal to x, like this. The slope will be 1 because from every unit on the x-axis, y output will increase by 1. And we will be starting from 0. From intercept 0, so b will be also 0. But what if I wrote epsilon is equal to 2 times x plus 1. It will be the same, but the slope will be 2. That means for 1 unit on the x-axis, it will increase the output by 2. And the 1 means that it will start from 1. Let me draw the graph. It will go from here, something like this. In the 2 on the x-axis, it will be equal to 5. As you can see, the 2 give us a linear slope, and the 1 put the function 1 value higher. The same applies for minus values. It will just go the opposite way, like this. Let's move on to the derivatives. Derivatives are easy. For this example, I have also the boat from Titanic, but now it is sinking. I will draw a function alongside these boats. It will be this axis will be y and this will be x, and the function will be y equal to x to the power of 2. And we would like to solve how much they need to climb over 1 unit on the x-axis. How much on the y-axis. For example, if you put here 1 and here 2 and put these values into that function here, for 2 you will get y is equal to 4, and for 1 you will get y is equal to 1. Then you subtract 1 from 4, you will get 3. So on this 1 unit on the x-axis, they need to climb 3. But derivatives are not for intervals, but they are only for 1 point, for that 1 and for 2. And they are showing you the slope in that 1 point, like how much they need to climb in that certain point. There is a lot of useful equation how to count derivatives. I will link you video to the bio. But basically you put the exponent before the x and you decrease it by 1. So now you have the first derivative. That means if you insert the point on the y-axis, you will get the slope of this function in that point. For example, if you put here 2, you will get the slope in the 2 on the x-axis. Here, there is slope 4. Now we are getting to the main and more funnier idea, to the simple linear regression. We are continuing with the Titanic film. They are getting dressed to the dinner and we will predict how much they will eat with the input values of their weights. For example, there will be their weights and eaten food, EF. It will be something like this. it will give us this line that will predict future values. How it is done? In the first slide, you saw the equation for linear function. It was y equal to a times x plus b. Our input values will be like this. For example, this will be the weight of the customer. It will be in kgs, and this one will weigh 130 kg, and at this table he will eat 0.9 kg. That will be the y value. The second person will be Rose. She is heavy as fuck, 80 kilograms, and she will eat also 600 grams of food. That means we need to declare a hypothesis. It is similar, it is not the similar, it is almost the same as the linear function. Theta 0 plus x times theta 1. What does these letters mean? The theta 0 is the intercept, the b, and the theta 1 is deciding the slope as the a before the x, and the x is the input value. Now we will get this purple line with the cost function j from the two parameters theta 0 and theta 1. It is equal to 1 over 2m. M is number of samples multiplied by sum of the h. The hypothesis will be giving us y, but our predicted y and the real y will be stored here. So we will do sums of our predicted y's minus the real y to the power of 2. So basically, we will count this area from that line, and we will be trying to minimize the cost function, which is this j. Lower the cost function will be, the better our predictions will be. But we won't do just one iteration. We will iterate many times this function here to get better predictions. Remember the derivatives. These parameters, theta 0 and theta 1, are giving us how much y is dependent on the input parameters. So we can insert this equation to the cost function, and we will get j equal to 1 over 2 times number of samples multiplied by sum of the literally linear function and minus the real output to the power of 2. To minimize this function in every iteration, we need to make the derivatives. As you remembered, there is a function, there is a point, and the derivatives will give us the slope. And we need to go the opposite way to minimize every parameter. To do it, we need to make partial derivatives. There will be also video for partial derivatives in bio. Partial derivatives for the cost function by the theta. This is just how you write it. Will be, for this you will use the simple calculus rules. Imagine these brackets like x, so you put 2 before the brackets, you put the bracket, and then you derivate also the bracket inside. So it will be equal to that constant that is multiplying this whole sum, 1 divided by 2m, 2 before the bracket, 2 times the bracket, and the inside of the bracket. But this is like the x, and if you derivate it, you will get 1. And this is constant, so you will get 0. And this is also constant, you will get 0. So in the bracket is 1. So simply it is 1 divided by m multiplied by the bracket. And for the theta 1 in the cost function, for the theta 1 it is slightly different because it is equal also to the constant before this. Our sum is 1 divided by 2m, 2 times the square, not the square, the brackets, and the inside of the brackets is this theta, but before this theta is x. It is like the current x from this data set. Theta 1 derivative, you will get x, y, the current x, and this will be 0, and this also 0. So multiplied by the current input. Now let me clear something. I will clear the inputs and our dataset. To iterate with this function, you need to change the coefficients after every iteration. The new theta 0 will be equal to the old one minus the learning rate, for example 0.01, because you need to just move slightly to the minimum. You don't need to like jump over to the next side and then back to the same side, minus the learning rate multiplied by the derivative. And there is minus, you wanna go the opposite way, like this equation. I will just write the partial derivative of the cost function, the respect to the theta 0, and derivate by the theta 0. And for the theta 1, we will do the same. It is theta 1 minus learning rate multiplied by the cost function derivated by the theta 1. And at the beginning of the code, you will set up the coefficient, these thetas, to 0, and you will basically get the maximum value of the cost function because the thetas will be zeros, so it will predict 0. It will go, this will be our first iteration, and the cost function will count it from this, and after every iteration we will be getting closer and closer, maybe we will jump higher than that, and in the last iteration we will get here. Like if you make more iteration, you will get closer, but for example in 1000 iteration you will just move like this slightly and you don't even notice, and it will take a lot of power, so you don't have to do it. This is the classic linear regression, but what if you have multi-dimensional input? Our multi-dimensional input will look like this. We will be having weight, also the age, and the number of money in the bank account, and the input value will be the same, how much food they will eat in the dinner. So it means eaten food. The biggest mistake here is thinking that when you have multivariate, that means multi-dimensional input, you will get like something crazy like 7 dimensions, polynomial with x to the power of 5. That's not true. The hypotheses which are giving the predicted input value will be almost the same, but it will have more coefficients. They are telling us how the input value is dependent on each parameter. So the hypothesis is equal to theta 0 plus theta 1 times x1 plus theta 2 times x2 plus theta 3 times x3. And these x's are wage, weight, age, and money in the bank account. The output value will be on the same 2D space. There will be just points. You will be still looking for a line that will describe this graph the best. The cost function is the same as previously. It is j dependent on the theta 0 to the theta 3. It is equal to 1 over 2 times number of samples multiplied by theta 0 plus, like this equation, 3 point theta 3 times x3 minus the real value, and there is sum over every sample. It is also to the power of 2. As I said you, the same equation, and after every iteration you will do the same. You will do the derivatives and you will move to the other side to get the local minimum. There will be difference between the derivatives of theta 1 and other thetas. For partial derivatives of theta 0 in that j function by theta 0, it is the constant before our x, 1 over 2 times number of samples multiplied by 2, the bracket, and inside of the bracket. So this is x, derivative is 1, all zeros, so times 1. And for the other, you will get the same. For I is bigger than 0, and I is equal to 1, 2, and so on. It is the same derivative, but in this bracket you are getting theta is derivated to 1 and you will still have the x. So times x, y. We will do the derivative for every coefficient after the calculation of the cost function. The same principles apply to the multivariate linear regression. Like we will start with the coefficients equal to 0, then you will do the cost function, you will get the max value, then you will do the partial derivatives, you will put those values into that equations, and the coefficient will change, the predicted value will be different, you will get closer, this will be less than the cost function before, then you will also count the derivatives again, and you will move to the different, like we will change the derivatives as I showed you before. So theta 0 is equal to theta 0 minus the learning rate times the derivative. I will write it like this. There's a not good notation, but whatever. And that is basically all. Maybe I made a small mistake because the input have more dimensions and it maybe will be like more dimensions here, but you will still be getting the simple line for the prediction. This is how you predict one value from multi-dimensional inputs. You can use this literally for any project. Thank you for watching. Like, this won't get so many views as the last videos, I know that, but this will give you more value, definitely. So thank you guys. Bye. Peace.